28 question number. The concentration of minority carriers in an extrinsic semiconductor and at equilibrium is given. Three words in this we need to remember. First, we need to find minority carrier concentration in extrinsic semiconductor and at equilibrium condition. This is main important. At equilibrium conditions, extrinsic semiconductor means it is doped. So equilibrium condition, we need to discuss about the equilibrium condition here. At equilibrium condition, whether it is pure semiconductor or p type or n type, pure these two are impure, means these two are doped. Pure semiconductor or impure semiconductor, number of electrons into number of holes is equal to Ni square according to the mass action law. Means at equilibrium condition, every semiconductor must satisfies the mass action law. It should be satisfied mass action law. In this case of P, number of majority carriers are Na and minority carriers are Np into Ni square. In case of N type semiconductor, majority carriers are Nd, minority carriers are Pn into Ni square. In these three cases, it should satisfy this minority carrier mass action law. Now, given that minority carriers in case of extrinsic semiconductor, in these two cases, we need to consider these two cases now. From this, minority carriers is equal to Ni square by Na, means doping of acceptors. Similarly, here also minority carriers means minority carriers are holes here, Ni square by Nd. At mass action law satisfying means at equilibrium condition, Ni is constant. Here also Ni is constant. Therefore, in case of p type, number of minority carriers or electrons are inversely proportional to the doping concentration. Na is the doped acceptor concentration. Here Nd is the doped donor concentration. So here also magnetic holes are inversely proportional to the Nd, means doping concentration. So from these two cases, we know that minority carriers are inversely proportional to the doping. Minority carriers are inversely proportional to the doping. This is our required answer for this question. For concentration of minority carriers in extrinsic semiconductor at equilibrium condition is option B is correct. Inversely proportional to the doping concentration. We need to remember this mass action law. It satisfies that equilibrium condition.